Example number 2, textbook, we're going to use those same parametric equations, but they ask us a couple of questions. They say use a graphing calculator to find the points. Well, I did that in example 1, but we'll do it again just to kind of show you guys how it's a little different. Then it's just use the graphing calculator to show the relationship in the xy plane. Is y a function of s? Find the algebraic relationship between x and y. Well, example number 2 is almost identical to example number 1, except example number 1 we did a lot of that stuff algebraically. Now we're going to try to do it completely graphically. So the one thing that I want to show you guys that's a little different is this is our parametric equation, and we said that it's y equals x squared minus 1, right? That's what we solved in the last equation. But y equals x squared minus 1, does it look like this? No. Let's see what that is. So what I'm going to do is I'm going to go to mode and go back to function, and then I'm going to hit graph. Well, I don't have anything entered in there, so I'm going to have to enter in x squared minus 1. Then we hit graph. How come when we graph the parametric equation it doesn't look the same as our Cartesian equations? Yes? Maybe. Well, let's look at it first, okay? If I hit trace and I come around here and I don't know, I'm just going to randomly plug in like -3. Okay, I get 8. If I plug in -2, I get 3. If I plug in -1, now these are the x comma y values, right? Now let's change our mode back to parametric. Now if I hit graph and I hit trace, if I plug in -3, what do I get? An error. Why? Well, remember that we could set the table values, and so that's the only thing. We could set the table values and when it's in function mode, but if I go to second window, which is table set, my table starts at -3. Now, is that the x or the y value or the t value when I'm in parametric mode? That's the t value. So I'm going to put this at -10. But now here's what's a little different. If I go to zoom, actually I want to go to window. If I click on window, what is my t minimum in the window? 0. So I'm going to need to change that to I'm just going to change it to -5, and we'll let this go to 5. Now when I hit graph, I get the whole thing. Does that make sense? So we have to be very careful when we go to do our work on our calculators to with the parametric equations. It's kind of like t has a domain. You have to figure out all the values that you could use for t. And if the domain of t is all real numbers, then you have to manually go into the calculator and set the numbers as you need them. Does that make sense? Now watch this. When I go to the table, it will only, it'll go to whatever, but what graphs, it doesn't start graphing until -5. Now the values are still the exact same, right? When it was -3, what was my y value when x was -3? See, I got a little bit different numbers here now. T has to equal -4, and I get -3 comma 8. Does that make sense? Where if I come in here and I go to function mode and I hit -3, oops. If I set x equal to -3, I get y equals 8. But when I change my mode to parametric, it has to be done a little differently. I have to enter in -4 for t, which will give me a -3 for x, but it still gives me 8 for y. Does that make sense? Any questions? Now, did we answer all the questions out of the textbook? Oh, we needed to show the relation. I did that before, but we'll show you again. Well, what's the relationship between x, y, and all that stuff? It's all based on t. So if you look at the y values, at the xy values, I've got 0, -1, 1, 0, 2, 3, 3, 8. Those are the xy values, but they're based on the t values of -1, 0, 1, 2. Now if I change my mode and I come back to function mode and I look at my table of values, I still get the same x and y values, but there's no t. Does that make sense? Alright. Now that's one way to double check to see if you've got the correct Cartesian equation. Is y a function of x? Yes, we did that in example number 1. We solved it. We said it was x squared minus 1. And then we found the algebraic relationship, right?